In this video we're going to talk about stem and leaf diagrams, also known as stem and leaf plots or stem plots. Stem and leaf diagram is a useful way of presenting data because it shows all of the original data and also gives you the overall picture or the shape of the distribution. They're quite similar to horizontal bar charts, only this time the numbers make up the bars for this. Alright. Now the way that this would work is that if you, for example, were given the number 42 as a number to be put in there, it will be represented as a 4 to one side of the line that we've got drawn on our diagram, so this is going to be the stem part, and you'd have a 2 to the right of the line, which would be the leaf, representing the completion of the number. And you can see some examples of this over here. So the number circled there represents 17. And for example, on the line below, this 3 is 23, so is that 3. This 6 represents 26, and this 8 represents 28, and so on. Whenever we put a stem and leaf diagram together, we have to include a key, which is down in the bottom of our diagram here, to make sure for certain that we explain how to read off the numbers from our diagram. So in our diagram here you can see this is our stem down the left, we've got our leaves all to the right, and the data that's being represented by that set is just beneath it there. Let's take a look at our question for this and see how this might be done. So what we have here is the number of minutes taken to complete an exercise was recorded for 24 students in a class. The results were as follows, and they're given the list of times that it took to complete an exercise. We are asked to represent the data in a stem and leaf plot. And the reason I've got 2 here is because typically when you're putting this together, you might not put it into numerical order to start with. You might just start by taking note of all the numbers first, and then order it second. So that's what we're going to do. We're going to start by just filling in the left-hand one without putting the numbers in numerical order, and then we're going to tidy it up for the second one. The stem itself, though, that's going to be in order. So we're going to look for the lowest numbers on this. Our smallest numbers are all single digits, so are going to be like 6, 8, and 9. So that's going to be a 0 on our stem. And then the largest number on these is going to be 38. So we're going to fill the numbers in between on our stem for this. So it's going to be 0, 1, 2, and 3. And then we're going to fill in the leaves to match that. And we're just going to go through this in the order that it's written out now for the moment, just make it easier on ourselves. So all of the single digit ones are just 9, 8, 8, and 6. Then all the teens, all the ones in the 10 section, it's just going to be 7, 4, 8, 5, 1, and 7. For the 2s, we're going to have a 0. And then 4, 5, 1. 6, 1, 3, 5. And then for the 3s, we've got 6, 2, 8, 7, 2, 6. Like that, just reading them off that diagram. And now when we're putting them together in order, I'm just going to tidy them up a bit. So the zeros are going to be 6, 8, 8, 9. So in numerical order. The 1s are going to be 1, 4, 5, 7, 7, 8. So 1, 4, 5, 7, 7, 8. The 2s, we're going to have 0, 1, 1, 3, 4, 5, 5, 6. And then for the 3s, we're going to have 2, 2, 6, 6, 7, 8. Like that. And you notice that I've spaced the numbers as evenly as possible to match up so that they line up going down. So we get a proper look at the distribution. The 2s weren't cramped together to fit underneath the 1s and between and above the 3s. They were just let to go out like that. And the only thing missing from both my diagrams at this point is a key. So our key in this place is just a way, we just have to give an example from above of one of the numbers that's being represented. So for example, if we say 0, 9 equals 9. Sometimes you get 2 keys given just to be sure, so we could also say that 3, 8 is equal to 38. And we do the same thing on our other one when we're finishing off giving it up. So it's going to be 0, 9, that equals 9. And we'll use the same example as before, so 3, 8. equals 38. Always have to make sure to include a key when we're putting these together. I'm just going to take a look at one other way that these might be given to us, another way we represent the data. So in this one here, we're asked to use a stem and leaf diagram or stem plot to complete the examination marks in history and geography for a class of 20 primary school students. So we're given all the data there, and this time what's happening is we're using a back-to-back stem and leaf diagram. And we got to make sure that we label which set of data is which. So we've got our history ones going off to the left and our geography ones off to the right. Now the thing about these this time is going to be a little bit different, because you notice that off to the right everything works the same as before. A 6 to the left of the line and a 3 to the right means 63. That's grand. But all of the 10s from our digits have been represented in the center. So for history, a 3 to the right of the line and a 1 to the left means 31, not 13. We're not reading it left to right for the data set that's on the left. So this would be useful for putting two data sets that are put together like this, like a history and geography. And you might be given questions like that. Again, it's the same as before. You give your key, you space out your numbers, and you make sure to write them out in order. The order that one's going out to the left, start with the smallest number closest to the stem and work outwards. And then to the right, again, same thing, smallest number close to the stem, and they work outwards. And that's stem and leaf diagrams.